Video, I talked about the law of sines, which is a tool you can use in trigonometry to find the angles and side lengths of a triangle. I've restated the law here, which basically just says that the sine of an angle over the length of the side across from it will be the same value no matter what angle you choose. So we could choose A and little a, or C and little c, or B and little b, and all these values are going to equal the same number for a triangle. We also talked about a few different problems that you will encounter using the law of sines. The first type of problem was a side-side angle problem, SSA, wherein you're given the lengths of two of the sides. I'm going to make up some numbers here, and one of the angles. And so with that information, you're expected to find the missing angles as well as the missing side. The second type of problem was an angle side problem, where, as the name suggests, you're given two of the angles and one of the sides, and then you need to find the missing angle as well as the other two sides. For the two examples that we did in the previous video, there was one triangle that satisfied the given constraints, but in this video I want to go over a unique type of side-side angle problem. So I'll put it up at the top here. And that is the two solution side-side angle problem. You might be wondering how that could be the case, but let me show you. So given our triangle here, this is going to be A, B, C. This is going to be 58 degrees, 12.28, and 11.4. All right, so for this side-side angle problem, we have A, which is good. We don't know C, and then we don't know either of the other two internal angles. So to start off, what we can do is we can just find B. So we're going to start with a little sine A over little a equals sine B over little b. Plug in our values. Sine B over 12.8 coming from there. All right, then if we work this out, this is going to be 0.9522 equals sine of B. So basically I just did that and I multiplied 12.8. Then if we do the inverse sine of this value, we will find out that B is equal to 72.21 degrees. But if we look at the unit circle, which is the circle with a radius of 1, and we look at where 72 falls, we should also realize that this angle will have the same sine value, because if you remember from the unit circle, the sine value is the y coordinate. So for this is our initial value, but this value over here, or this angle, has the same y coordinate. Clean this up a tiny bit. This is going to correspond to 72.21 degrees up from 180. So we actually have two possible angles that we need to test out, which is what we're going to do next. we've already found case 1, which was our 72.21 degrees. Now we have to find case 2, which is really just a matter of subtracting 72.21 from 180 to give us 107.79 degrees. And if we plotted this over here, I'm going to have to get a smaller eraser. That is this angle, 107.79. Okay, so we have two options for our triangle. And we'll need to plug those in to see if they actually work. So let's give ourselves some space here. We're gonna save this one up here. Oops, I'm gonna save this one as well. We're gonna start with case 1, 72.21. And we're just gonna redraw this triangle quickly. 58. And these are B. We're going to plug in 72.21 here. This is C, C, A, B. Okay, so to find C, we just have to take 180 and subtract the two values that we have, which is 58 and 72.21. That's going to leave us with 49.79 degrees. So that looks plausible. Now we can use the law of sines to figure out what the actual length of C in case 1 would be. So actually let's block this off just so we know that we are working just on case 1 right now. So we're going to start with what we have. A over sine of A. So basically I'm using this pair and the one that we're looking for. C over sine of 49.79 equals 11.4 over the sine of 58. We do all this math. I'm going to bring the sine over here. C is going to equal 10.27. Alright, so that is for case 1. Actually, let's see if we can. We'll draw case 1. Case 1, we have an angle of 72.21 degrees, and C is 10.27. Case 2, which we'll work on next, we're starting with an angle of 107.79 degrees, and we'll have to figure out what the possible C value is. When we draw this one out, the shape of the triangle is just going to look a little different to accommodate for the potential value or angle value that we calculated. So, see, this is still going to be 58. This value is going to be 107.79. And we're looking for, we need to find C. This value is 12.8 still, and this value is 11.4. Alright, so step 1 again is to find C, this one, by subtracting the stuff that we know. C equals 14.21 degrees, which looks appropriate for this triangle. So this angle is very acute, So 14.21 seems like it makes sense. Now we want to find C, the side length. So we're going to start with, I'm going to clean this up. We're going to do C over sine of C equals B over sine of B. So I'm using these two values and then the one that we're looking for. Now let's plug in what we know. Equals 12.8 over sine of 107.79. Now we're going to multiply this over. Little c is going to equal 3.30. All right, so after doing all that, we basically realized that given the initial side angle of 12.28, 11.4, and a equal to 58 degrees, we have two very plausible solutions, or two solutions that actually fit the constraints. In the next video, we're going to look at an example where there is actually no solution or no triangle that satisfies the constraints.